These are 6 things happening in the ocean right now that should not be possible. And in most cases, science took decades to even begin explaining them. The ocean covers more than 70% of Earth's surface, and less than 5% of it has been explored. What we have found in that 5% already breaks the rules. The tallest waterfall on Earth has never been seen by a single human being, and it is not Angel Falls. 11,500 feet. That is how far water drops through the Denmark Strait, between Greenland and Iceland, in a cataract sitting 2,000 feet below the ocean surface, where no light reaches, and no camera has ever captured it cleanly. Angel Falls, the waterfall that every geography textbook hands the title to, drops 3,212 feet. The Denmark Strait cataract drops more than 3 times that distance, moves approximately 175 million cubic feet of water every second, and carries between 20 and 40 times the combined flow of every river draining into the Atlantic Ocean. Niagara Falls moves 2,000 times less water. None of that is detectable from the surface above it. What drives this is a collision of densities. Cold water from the Nordic seas, chilled by the Arctic, is denser than the slightly warmer water of the Erminger Sea to the south. And when these 2 bodies meet at the Greenland-Iceland rise, the cold water does not mix with anything. It sinks, slides to the edge of the ocean floor, and cascades downward across more than 300 miles of seafloor slope. Marine scientist Ana Sanchez-Vidal, who led a research expedition to the strait in 2023, described the surface conditions as typical sunny Arctic. Nothing unusual. No sign of any movement below. The waterfall itself is invisible from space except through temperature and salinity readings. And a marine geosystems expert at the UK's National Oceanography Centre put it this way: if you were in the water directly above it, you probably wouldn't notice a whole heap going on. And this is where the scale of it stops being just a number. The Denmark Strait cataract is one of the primary drivers of the thermohaline circulation, the global ocean conveyor belt that moves heat around the planet, moderates European winters, and cycles oxygen through the deep sea. The entire time that system has been regulating Earth's climate, it has been powered in part by a waterfall that no human has ever witnessed. On the floor of the Gulf of Mexico, the Mediterranean, and the Red Sea, there are lakes. Not geological formations that resemble lakes, not sediment patterns that read as lakes on sonar. Actual bodies of liquid with their own surfaces, their own shorelines, their own slow-moving waves, sitting inside the ocean while refusing to become part of it. Anything that swims into one dies within seconds. The reason comes down to salt deposited during the Jurassic period, somewhere between 150 and 180 million years ago, when the Gulf of Mexico was a shallow sea that evaporated and left a buried salt layer up to 8 kilometers thick. Pressure from sediment above eventually cracked those deposits, and the dissolving salt produced a fluid 3 to 8 times saltier than normal seawater, dense enough to sink into floor depressions and stay there permanently, unmixed, forming a separate body of water with a visible horizon. ROV footage of these pools looks wrong in a way that takes a moment to process. There is a surface down there, a shoreline, a distinct boundary between the brine and the water above it. In 2015, researchers aboard E/V Nautilus found one in the Gulf of Mexico, roughly 3,300 feet below the surface, about a day's boat ride from New Orleans. The name they gave it was the Jacuzzi of Despair. 100 feet in circumference, 12 feet deep, 5 times saltier than the surrounding sea, laced with hydrogen sulfide and methane, and littered with the preserved carcasses of crabs that wandered in and never came back out. The brine doesn't just kill them, it embalms them. Life has adapted to the boundary though. Shrimp hover at the halocline, the thin membrane where seawater meets brine, waiting for fish or crabs to drift too low and become stunned, darting in to grab them and retreating before the water overwhelms them. They have turned the chemistry of a death trap into a hunting strategy. Around the rim, mussels crowd in dense beds, kept alive by bacteria processing methane and hydrogen sulfide into energy. Gulf of Mexico pools range from 1 meter across to 20 kilometers long, and in the Red Sea's Gulf of Aqaba, A pool system discovered at 1,770 meters deep has given scientists something else entirely. Sediment layers preserved in perfect condition by the same chemistry that kills everything above them, holding records of ancient tsunamis and earthquakes that the open ocean would have destroyed long ago. Lead researcher Dr. Sam Purkis described the environment simply as incredibly inhospitable, which, given what it contains, qualifies as an understatement. 400 years of sailors recorded it, vast stretches of open ocean glowing at night, not flashing, not flickering, but holding a steady, sustained, milky white light that extended to every horizon, bright enough to read by. Officers dismissed the accounts. Logbooks preserved them anyway. And what those logs describe again and again is a sea that, in the words of the sailors who witnessed it, looked like a daylit snowfield extending in every direction. Jules Verne wrote it into 20,000 Leagues Under the Sea and attributed the glow to a giant luminous worm. The worm was fiction. The sea was entirely real, and between 1915 and 1993 alone, researchers catalogued 235 documented sightings, a rate suggesting it occurs at least 3 times a year somewhere in the ocean. More than 70% of those cases happened in the northwest Indian Ocean, with nearly 60% clustering specifically around the waters near Somalia, Socotra, and Yemen. And in 2025, researchers at Colorado State University published the first comprehensive sightings database assembled in 30 years, drawing on 4 centuries of sailors' accounts alongside modern satellite data. That database revealed a statistical connection between Milky Sea events and the Indian Ocean dipole and El Niño, though exactly how the connection works remains open. The cause is almost certainly a bioluminescent bacterium called Vibrio harveyi, capable of producing a continuous, steady glow rather than the brief defensive flashes associated with plankton. A research vessel sailed through a Milky Sea in the Arabian Sea in 1985 and collected a sample that confirmed the presence of bioluminescent bacteria. And that encounter remains the only time in recorded history that scientists have been inside one. 235 documented sightings, at least 3 per year, and exactly 1 direct scientific observation since records began. Satellite detection later confirmed a patch approximately 15,400 square kilometers, roughly the size of Connecticut, glowing continuously for 3 consecutive nights in the northwest Indian Ocean. Historical accounts place the upper range at 100,000 square kilometers. That is 39,000 square miles of ocean, holding a sustained glow in the dark, and science still cannot fully confirm why it stays stable, why the light holds the color it does, or what triggers the bacteria to behave this way at that scale. Point Nemo is not a place anyone chose. Croatian-Canadian survey engineer Hrvoje Lukatela ran a geospatial calculation in 1992 to find the single point in the ocean farthest from any land in every direction at once. And the math returned a set of coordinates in the South Pacific that no one had ever named. Lukatela named it after Captain Nemo from Jules Verne's novel, Nemo meaning nobody in Latin. And the name turned out to be accurate in ways he probably didn't anticipate. The 3 nearest pieces of land, Juicy Island in the Pitcairn Islands, Motu Nui near Easter Island, and Meher Island off Antarctica, each sit 2,688 kilometers away, and the water beneath those coordinates drops to 4,000 meters. The South Pacific Gyre, a massive system of rotating currents surrounding the area, actively pushes nutrient-rich water away from it, leaving Point Nemo among the biologically emptiest stretches of ocean on the planet, with no fish believed to inhabit the zone. When the International Space Station passes overhead, the closest humans to Point Nemo are the astronauts on board, not anyone standing on land. Space agencies recognized the value of this emptiness early. Since 1971, at least 263 spacecraft have been deliberately crashed here. Mir, 6 Soviet Salyut stations, and debris from multiple nations finding their way to the seafloor, with Russia contributing the largest share of roughly 200 pieces. The International Space Station is scheduled to join them in 2031, with deorbit maneuvers potentially beginning as early as 2026, and debris from a single controlled re-entry can scatter across nearly 1,000 miles of ocean floor. Some of those spacecraft carry hydrazine, a highly toxic rocket propellant, alongside radioactive materials that are believed to survive re-entry, and the environmental consequences of decades of deposition at that depth remain poorly understood, because studying the site requires the kind of sustained access that Point Nemo makes nearly impossible by definition. What nobody expected was the microplastic finding. During the 2017 to 2018 ocean race, water samples collected near Point Nemo came back with up to 26 microplastic particles per cubic meter. The most inaccessible point on the ocean's surface is not clean. Summer of 1997, and NOAA's Equatorial Pacific Ocean Autonomous Hydrophone Array, a network designed to monitor seismicity and marine mammal migration, picked up something that matched nothing in the existing record. The sound lasted approximately 1 minute, its frequency rising steadily in a pattern consistent with biological vocalizations, and hydrophones 5,000 kilometers apart detected it simultaneously. Amplitude louder than a blue whale, the largest animal ever to exist, with an acoustic profile that pointed squarely at a living organism of a size that has never existed. Researchers called it the Bloop, and the source triangulated to a remote point in the South Pacific west of the southern tip of South America. NOAA had no explanation that fit. Theories filled the gap: unknown megafauna, military operations, something living in the deep trenches, and the ocean, which is approximately 95% unexplored, offered nothing to rule any of them out quickly. The answer arrived 15 years later. In 2012, NOAA officially attributed the Bloop to a cryoseism, a massive fracturing of Antarctic ice, consistent with the carving or seafloor scraping of a large iceberg. Seismologist Robert Giac confirmed to Wired that NOAA's hydrophones detect tens of thousands of similar sounds every year, and the 2008 disintegration of iceberg A53A near South Georgia Island helped pin down the mechanism. Oceanographer Chris Fox at NOAA had suspected ice as the cause as early as 2001, and the scientific community largely set that suspicion aside for over a decade. But here's the thing: the resolution doesn't shrink the anomaly. The icequake required to produce a sound louder than a blue whale, detectable by instruments 5,000 kilometers apart, represents a release of energy that the phrase "breaking ice" does not begin to capture. Nature produced something that, measured against every available tool in 1997, appeared to be statistically impossible. And the explanation turned out to be not a monster, but a process operating at a scale that is its own kind of staggering. Every model of oxygen production on Earth rests on the same foundation: photosynthesis, the conversion of sunlight into energy by plants and bacteria, releasing oxygen as a byproduct. No sunlight means no oxygen production. That is not a hypothesis. It is the base assumption that underlies the entire history of how life developed on this planet. In July 2024, a paper in Nature Geoscience put that assumption under pressure. Andrew Sweetman, who leads the Seafloor Ecology and Biogeochemistry Research Group at the Scottish Association for Marine Science, was conducting fieldwork in the Clarion-Clipperton Zone, a submarine ridge extending nearly 4,500 miles across the northeastern Pacific Ocean at depths between 4,000 and 6,000 meters. Sealed chamber experiments on the seabed returned a result that initially read as equipment malfunction. Oxygen levels were rising. Over 2 days, they climbed to more than 3 times the background concentration, in complete darkness, 13,000 feet below the surface, with no photosynthesis possible. The team, working alongside electrochemistry researchers at Northwestern University, led by Professor Franz Geiger, identified a likely mechanism. Covering the seafloor of the Clarion-Clipperton Zone are polymetallic nodules, potato-sized mineral formations containing cobalt, nickel, copper, lithium, and manganese, and voltage measurements on individual nodule surfaces reached up to 0.95 volts. A standard AA battery produces 1.5 volts. The hypothesis that followed was that these nodules function as natural geobatteries, splitting water molecules into hydrogen and oxygen through seawater electrolysis in the absence of any light, producing what the researchers named dark oxygen. Sweetman stated it plainly. Their understanding had always been that Earth's oxygen supply began with photosynthetic organisms, and what they found in the Clarion-Clipperton Zone was oxygen being produced where photosynthesis cannot reach. The consequences extend in near 2 directions at once. If oxygen can form without sunlight, At crushing pressure, through electrochemical processes in mineral formations, the parameters for where life might exist, on this planet and elsewhere, shift considerably. And those same nodules are currently the targets of large-scale deep-sea mining operations, with Geiger warning directly that several major companies are already planning to extract these materials from depths of 10,000 to 20,000 feet, and that the oxygen source for deep-sea life must not be depleted before it is understood. One caveat belongs here, and it matters. As of April 2026, the Nature Geoscience paper carries an editorial notice flagging that aspects of the study are under active review by the journal. A critique published in Frontiers in Marine Science in late 2025 noted that no other study has independently reproduced the dark oxygen findings, and that multiple prior experiments in the same Clarion-Clipperton zone measured only oxygen consumption, never production. The science is contested, the debate is ongoing, and that is precisely where discoveries of this weight tend to live before the field catches up with them. 5% of the ocean explored, and 6 anomalies found inside that 5% alone. A waterfall more than 3 times taller than any on land, moving more water than every Atlantic river combined, that no human being has ever seen. Lakes on the seafloor that kill and embalm everything that enters them, holding centuries of geological history in their layered sediment. Thousands of square miles of open ocean glowing in the dark, documented for 400 years, directly studied exactly once. The most remote point on Earth, carrying spacecraft debris and microplastic in equal measure. A sound in 1997 louder than the largest creature that has ever lived, produced not by anything alive but by ice fracturing at a scale that defies easy description. And oxygen appearing in total darkness, 4 kilometers below the surface, from mineral nodules behaving like batteries. None of these were predicted. All of them were found by instruments pointed at a part of the planet that remains almost entirely unknown. What exists in the other 95% has no answer yet, and that may be the most consequential fact about the ocean that science currently holds.